Hey math kids, today we're going to talk about logarithms and specifically in base 10. And this might be your first exposure to logarithms. So at this point we just want to think of them as the inverse to an exponential function. And so let's just talk about it a little bit in that. So we've been studying exponentials. We know that it crosses at 1 right here, right? So that's just some exponential. Now, we've also studied inverses, and so we know that inverses are reflections across this line y equals x. And so what that's going to do is it's going to create a situation that kind of looks like this. Maybe I should do it a little bit better. All right, so that means it's going to cross the x-axis this time at 1, and just like the exponentials had a horizontal asymptote, logarithms have a vertical asymptote as the y-axis. So that's really all you need to know as far as like how they relate to exponentials. They are the inverse. And so eventually we will get into like doing algebra and like how to undo an exponential function. That way we don't have to rely on technology like we did before. We will learn how to do those by hand. Okay, so another thing, just some notation. If you ever just see log x, that is the same thing as saying log base 10 of x. So base 10 is one of the most common logarithms, and so the shorthand is just to write it as log. So if you ever see log, it's a base 10. Now we could see things like log base 2, log base 3, etc. And there actually is a natural log, which is the same thing as log base e, but I will do a video just on that, so don't worry too much about that right now. Okay, let's jump into the type of problem that you'll see on your homework. So we have log base 100. Now remember, this is log base 10, or sorry, this is not log base 100. It's log base 10 of 100. Now, a cool property about logs is if we make an exponential like this, like 10 raised to the 2, if the log base is the same as the base of this exponent, they cancel. And so the answer to this is just 2. Okay, let's try another one. So we have log 4th root of 10. So once again, when it's just log, it's log base 10. And then this 10 can be written as 10 to the 1/4, if you remember that lesson we had a while ago. So log base 10 cancels the base 10 on the exponential, and so the answer to that is 1/4. Okay, this next one says, use your calculator to write the following in the form 10 to the x, where x is correct to 4 decimal places. Okay, so the first one is just the number 8. So basically we want to say that 8 is equal to 10 log 10 of 8. And so what we need to know is we need to know what is log base 10 of 8, and that's going to answer this question. So let me open up calculator. Now your calculator only has log base 10 and natural log. So luckily we only want log base 10. So we just say log 8, and we get 0.903. Okay, and so we would write that as 10 raised to the 0.903, and that is approximately 8. Okay, now we have the number 800, and so we're going to go through the same process. So we're going to have 10 raised to log 800, and so log 800 is 2.90. 2.90, and so that is approximately 800. Okay, now we have 0.08, So we're going to do 10 raised to the log of that. And so we just say log 0.08. We get negative 1.10. And that is approximately 0.08. Alright, those are just trying to help you kind of wrap your head around how logs work. Okay, now it just says use your calculator to find log 2 and log 20. And then it wants us to explain why log 20 is equal to log 2 plus 1. Okay, so we have log 2.301. And then based on this question, I'm sure it's going to be 1.301, but let's just double check that. So log 20. Yep. So it is 1.301. Now, it's asking why is log 20 log 2 plus 1, because we just saw that that's what happens right there. We haven't learned log rules yet. So I'm trying to think how they want us to do this one. But I know log rules, and so what we're going to do this in a different video. So I'm going to just follow along with how they do it and try to explain it that way. I think it's easier with log rules, but I think we'd have to have a whole video on log rules before, so it might seem a little overwhelming. So what they do is they think of this like log 2 times 10. So they just break the 20 up into 2 times 10. And then they do 10 log 2. So 10 raised to the log 2. And then times by 10. Like that. Now, if we do it that way, we can add the exponents. So we get log of 10 raised to the log 2 plus 1. Like that's all one exponent, because the exponent right here was just 1. Okay, and then if we apply the log, so remember this is log base 10, so this cancels this, then we have log 2 plus 1. And so that's the reasoning on how this thing equals this thing, and we saw with technology that that holds up as well. Okay, now we want to find x, so log x equals 3. Okay, now here's where we're going to start doing some algebra. Now this is a base 10, remember. Now what we're going to do, I call it big 10, so whatever the base of the log is, if you want to get rid of it, just do a big whatever that number is. So I'm going to big 10 both sides. These cancel, so we're left with x, and then this is 10 raised to the 3, and if we simplify that, that's 1,000. Okay, now we have log x is approximately negative 0.271. Okay, once again, this is a base 10, so I'm going to big 10 both sides, cancel those, so x equals 10 to the negative 0.271, and so we go to our calculator, 10 raised to the negative 0.271, hit enter, and we get 0.536, so x is approximately 0.536. Okay, so that's it we have on base 10. If you need additional help, please come to MathLab. Until then, calculator.